for the Love of Weather. This is the podcast where we explore the Earth's atmosphere and how we are all connected through the weather and climate. We're your hosts. Hi, I'm Gemma.
And hi, I'm Aisling. We're both meteorologists, weather presenters, and climate chatters experts, communicators. We like to call ourselves that. And we love chatting about the weather and climate. We hope that you enjoy this episode and leave loving the weather just a little bit more, learning something new about how the weather and climate can impact our daily life. Our guest today is Paul Williams, Head of Department and Professor of Atmospheric Science in the Department of Meteorology at the University of Reading. Kind of a rock star in science terms, really, with that title. He specializes in atmospheric turbulence, jet streams, climate change, with a focus on weather sensitive applications, including aviation. He co developed an award winning aviation turbulence forecasting algorithm. That's a lot to get in, isn't it? But it's made billions of air passengers' journeys smoother and safer, and discovered that climate change is making the atmosphere more turbulent. So we're going to be speaking to Paul about all of that today, and we can't wait to learn a little bit more. But before we get there, Paul, where did your very first spark of joy, that just moment where you looked up at the sky one day and thought, well, I might do something with the weather? Where did that come from?
Well, hi everyone, and nobody's ever called me a rock star before, so thank you, Ash, for that. That's a first, first and last, I think, probably as well. But I'm going to enjoy it just for today. Where did it all come from? I've got colleagues who lecturers at the University of Reading who say that ever since they were 5 years old, they've been in the garden looking up at the clouds, or they remember a big storm or a big wind event and trees were blown down. I can't say any of that. That's not what inspired me, really. I had just the usual amount of interest in the weather for a child, which is probably not very much. I should be embarrassed to say that. I shouldn't be admitting this, but it came much later for me. I was studying physics at university and got to the end of my degree, and I began to think, well, what can I do with this knowledge? I've spent 4 years building up this knowledge about physical systems. I was quite keen on, this sounds a bit corny, but just making the world a better place, as sort of idealistic students are. I still have that in me. And I sort of moved a little bit towards climate and atmospheric modeling and fluid dynamics for my PhD. I studied some waves in the atmosphere called gravity waves, which are linked to turbulence, and maybe we'll come on to that link later. And then I finished my PhD and thought, again, what can I do now? What's the next step? How can I keep making the world a better place and use the knowledge I've acquired to improve the quality of life for people? It still sounds corny, but I still believe it. And so I moved slowly into turbulence modeling in the atmosphere, which of course affects people whenever they fly. How can we forecast it? How can we understand how it's changing in time with climate change as well? And so I've spent really my whole career since then, 25 years since then, studying turbulence and how it's linked to the jet stream in the atmosphere and atmospheric motions. And so that was my story. It didn't begin at the age of 5 looking up at a thunderstorm and in amazement and awe. It came much later, but when it did come, it was very strong. And I have a passion really for everything that goes on in the atmosphere now, whether it's clouds, lightning, hail, turbulence. I just love it all.
I love that. I mean, I think we're all kind of the same. I mean, I do have memories of looking up at the sky, and I always it's like, how do they know it's going to be warm tomorrow? Why is the cloud that color and all that? But ultimately, the journey was a little bit of a meander of like love, of like finding, oh, I really like doing that, and I really like doing this. And I think we're one of the lucky ones that we got to do that. We were able to kind of walk that path and find our way there.
Mm-hmm.
But the first question: what is the jet stream? How does it impact our weather?
Aha. The $1 million question. Well, it is a very fast air current that blows around the world from west to east. There's one main one in the northern hemisphere, there's another in the southern hemisphere, and actually there are other jet streams as well. But I think today we're going to focus on what we would think of as the main jet stream, certainly in the UK and in the mid-latitudes around the world, where many people live. The jet stream is blowing at 100, 150, 200 miles an hour on a fast day, blasting weather systems across the Atlantic to us in Europe. We talk about a storm factory where storms are born out in the Atlantic Ocean, the West Atlantic, and get blasted across the Atlantic by the jet stream very quickly. And they grow up, they mature, and then often will strike us in the UK. We'll be in the face of the jet stream, blasting storms towards us, and then of course they die out eventually. There's the life cycle of a storm, like a baby. It grows up, becomes a teenager, becomes an adult, and then sort of fades away. And the jet stream plays a crucial role in all of that. It also is the home of a lot of turbulence in the atmosphere. Just because it's blowing so fast, there's a lot of what we call wind shear in the jet stream. Wind shear is where the wind changes from one part of space to another, which could be vertical or horizontal. And the jet stream has both of those kinds of shear in it. Essentially, the higher up you go in the jet stream, the faster the wind will blow. That's wind shear. And it's also what generates turbulence. And so that's partly my interest in the jet stream, is that it contains about 3 times as much of an invisible kind of turbulence called clear air turbulence than the rest of the atmosphere.
So many questions about clear air turbulence. Before I get there, though, Kat, clear air turbulence. What size is the jet stream? So how wide is it? How deep is it? How big is the jet stream? If you had no idea what it looked like, and you could like drop some water into it, how big is it?
I always struggle to answer that question because it's not like the answer is a bit vague, because it's not like the jet stream starts here and ends here and sort of it's in a nice box and sort of here it is. And if you're here, you're in the jet stream. And if you're here, you're not in the jet stream. It's much more of a smooth transition, right? It's like a gradual, smoothed out sort of jet stream. So I think people usually say it's about 5 to 9 miles above the surface of the Earth, which is quite a range. But the reality is, if you go up the Eiffel Tower, it gets very windy. You're kind of experiencing the bottom of the jet stream, but you're nowhere near 5 miles up, of course. So it's really just a gradual increase in speed from the ground level, where usually it's not very windy because of friction with the ground brings the wind speed to 0 technically at the Earth's surface, but it gets windier and windier and windier the higher up you go, all the way to what we call the core of the jet stream, the center of the jet stream, which is at about 10, 11 kilometers. It varies. And then the wind speed reduces the higher up you go. So it's not like suddenly when you cross 3.972 miles above the surface of the Earth, that's where the jet stream starts. It's a much more smeared out sort of distribution, and the same horizontally as well.
And this is a question that myself and Ash have both asked and have been interested in. How is climate change actually impacting the jet stream?
Well, that's another $1 million question. You've got lots of those today, but I would call this a $1 billion question, actually. This is the most important one.
This is the one I get asked all the time, and I'm like,
Yeah.
well, there was some recent papers that said this, and some recent papers said that.
Exactly, and that's what piqued my interest. I remember seeing a few years ago a news story that said the jet stream is slowing down because of climate change. And I thought, okay, interesting, jet stream slowing down because of climate change. And it was a proper, peer-reviewed study published in a journal, internationally accepted by a panel of experts as being correct. And then it wasn't quite the next day, but sometime shortly afterwards, I saw another story in a different newspaper that said that the jet stream was speeding up because of climate change, kind of the opposite. And again, that was a peer-reviewed study published in a journal, kind of accepted by experts. So how can these both be true? The jet stream can't be speeding up and slowing down, can it? Sounds very contradictory. But actually, it is speeding up and slowing down. The jet stream is doing both of those things. They're both correct. They're both right, even though they sound contradictory. And that's because the jet stream can be changing in different ways at different heights. The jet stream is a complicated object. It has a vertical distribution. It changes in latitude and longitude. It changes in time. And that is the current understanding then of the jet stream, is that in the lower atmosphere, it's slowing down. It seems to be slowing down. But at the sort of altitude where aircraft will have their cruising altitude at about 35 or 40,000 feet, the best evidence is that it's speeding up, and there's no contradiction there. It can do both of those things at different heights at the same time. And so what seems to be a contradictory message, and I can completely understand why members of the public get confused and think, oh, these meteorologists, they haven't got a clue what they're doing. They're saying one thing one day, another thing the next day. Do you know, it's a bit like one day you'll read that red wine is good for you and it prevents heart disease and all sorts of nasty diseases, and the next day you'll say, oh no, a new group of scientists have said it's really bad for you and we shouldn't drink it anymore. It's a bit like that. But in this case, both are true at the same time. The jet stream is speeding up where aircraft fly and slowing down lower in the atmosphere. They're both true.
It's really interesting because, you know, I mean, I do more public weather service. So when we're talking about the jet stream, you know, we've got like 20 seconds to do it. And so much so that I am like versed myself in thinking about the jet stream and just kind of a portion of the atmosphere. So it's lovely to be reminded or revisited of the fact actually it's the whole way through, but it's just at its core there. But that makes really good sense. I'd never quite heard that. You know, so I'm reading these papers as someone who doesn't make papers, or I'm like reading these in the same as in like scientific papers.
Mm.
You know, I'm obviously not peer reviewing them, so it's really interesting to actually hear the expert say what exactly is happening. So it's doing both things at the same time. I guess
Yes.
the question then becomes, how are we expecting that to impact weather or climate? So whether it's the day to day or the slightly longer term, is there any evidence to suggest that because it is doing both, that we are possibly anticipating something coming from that?
I think this is where the jury is still out a little bit and we need more research. So, quite what this is going to do to weather systems, storms, mid latitude storms, I think remains to be seen. Um, so, the slowing down near the ground, people call that global stilling. Global stilling. It's not something people talk about a lot. We know about global warming, but here's a related thing: global stilling, where the surface wind speeds slow down, become stiller, I suppose. And it's a known phenomenon. The Intergovernmental Panel on Climate Change, the IPCC, writes about it in its reports, and that's expected to continue into the future. I think there's a projection of a 10% reduction in surface wind speeds in Europe in the summer by the end of this century, if I'm not mistaken. And that might not affect our weather very much. I don't know, but one thing it could affect very strongly is wind energy production, of course, because a 10% reduction in wind speeds, actually, because of a nonlinearity in the equations, means a 30% drop in the energy that we can extract from the wind. And so, you know, the renewable energy sector is rightly concerned about this global stilling. But then going higher up into the what we call the upper troposphere and the lower stratosphere, which is where aircraft fly, the increase of the wind speed there has consequences certainly for the way we fly, because of the headwinds and the tailwinds when you're on a flight. So if you're on a plane, a tailwind is a wind that's pushing the aircraft kind of faster, so it's coming from behind and blowing you to a faster speed than you would otherwise have, whereas a headwind is blowing towards the aircraft and kind of slowing it down. So we like tailwinds. They help us get to the destination faster, but we don't like headwinds because they tend to slow down the arrival. And as the jet stream speeds up at those altitudes, and we have a projection that it might speed up by about 10% by the end of this century at 35 or 40,000 feet, that will be kind of welcome news for anyone flying eastbound, because your flight will be quicker. But not good news if you're flying, for example, from Europe to North America on a westbound flight, because your arrival could be delayed as the headwinds get stronger. And there is perhaps some evidence that this effect is already started to be seen, because the eastbound flight time crossing record across the Atlantic from New York to London has been broken 3 times in the last few years. It used to be 5 hours 16 minutes from New York to London. Then it was 5 hours and 13 minutes. And today the record is actually under 5 hours. It's 4 hours and 57 minutes.
Whoa,
It's
that's
not that aircraft are any faster.
quite a chop.
Yeah, that's not just a few minutes shaved off, is it? That's a big chunk knocked off. Aircraft are not flying any faster in terms of their intrinsic, what we call their airspeed. So what could be happening there is the jet stream blowing them faster. And conversely, there have been some westbound flights that have taken off with what should have been enough fuel from London to reach New York, but the headwinds were so strong, the journey was taking so long, they were burning so much fuel that they had to make an unscheduled refueling stop when they reached Maine, because they didn't essentially have enough fuel to make it safely to New York. So that's the kind of thing we might see more often in future as well.
So you've mentioned sort of the impact on the person. What about storminess then? So is this where we get that messaging from, that increase in storminess in a changing
Potentially,
in a changing climate?
yes, there's a lot going on there because we're putting more energy into the atmosphere through the extra heat. There's more moisture in the atmosphere as well, more humidity, more water vapor. In fact, for every 1 degree Celsius rise in air temperature, the air can hold 7% more moisture. That's just a law of basic physics. And we've already had a warming of more than 1 degree Celsius. So the atmosphere can hold 7% more water today, more than 7%, than it could a few decades ago. And of course, water vapor is the fuel for many weather systems. So we have a lot more research to do on that front. We don't have all the answers. And this slowing down of the wind near the ground, but speeding up of the wind in the upper atmosphere is creating more wind shear, and that is a crucial ingredient for the generation of storms as well. So there's lots of different factors at play, and we don't have all the answers, but there is an expectation that when it rains today compared to a few decades ago or in the future, that there's the potential for 7+% more water to just rain out of the cloud. And so, the potential for extreme rainfall, flooding, and all the consequences is clearly there. And we see that clearly. We all know that when it rains now, it has the potential to flood more than it did decades ago.
I don't know whether you're the same, Gemma, but we look at so much stuff in isolation and wait, especially for you do a lot of messaging, for media, so you're really having to like chomp down what you're saying. But to hear that kind of overall picture being painted is I guess this thing that always surprises me about the weather. I never stop hearing things in different ways and learning something slightly new or seeing it in a slightly different way. It's fascinating.
I think experiencing it as well, because I have definitely been out and about with people and we've been driving and you get a really heavy rainfall, like a really heavy shower. And there are times when I've had my windscreen wipers on full and it's still not enough to clear the water. And it's because the rain's so intense. And we've had conversations between us as we're driving going, I don't remember having a shower this heavy when I've been driving through. And I'm definitely noticing that more now, that you get these really heavy rainfall events that I just don't remember having like 10, 15 years ago. I just don't remember having them.
I completely agree. So maybe car manufacturers are going to have to up their game a little bit and make those wipers go faster, which is an interesting example of adapting to climate change. Of course, we all want to stop the climate from changing. That's called mitigation, reducing our emissions. But I think now there's an increasing acceptance that that's not enough. The climate has changed and it's going to continue to change. So we need to adapt the way we live as well. And faster windscreen wipers might be one such thing. Another, in aviation, I have heard a story, well, a true story, of an aircraft that in South America flew through a thunderstorm. There's a question there. Why did it fly through a thunderstorm? Why? It shouldn't have been anywhere near the thunderstorm. But
Where was the
sometimes
air traffic control? Oh goodness!
something went wrong. But
Looking
anyway,
out the window, don't fly
it
into
was,
it.
exactly, you can see it. There must have been I don't quite know. Maybe it evolved very rapidly and it came out of nowhere. But there was hail, and it caused both the engines to fail. So the hail got into the engines, and so now it's flying along with no engines. Um, Thankfully, it managed to restart the engines and it landed safely. But the official safety report said that the hail content was twice the design specifications for the engines. So they'd been designed to cope with a certain amount of water vapor and hail frozen. But in this case, the amount in the engines was double what they'd been designed to cope with. So there's another example there, a bit like faster windscreens on a car. Do we need engines that can cope with more hail going into them in future as well. And the Airbuses and the Boeings of the world are very aware of this and kind of actively researching what the aircraft of the future are going to have to look like to cope with more hail, more turbulence, etc.
You've touched on it there. So we've touched on
Yeah.
how our flights from New York to London are getting quicker, will get quicker with a faster jet stream in the upper part. But how is that impacting already, or how could it impact turbulence, particularly as you mentioned clear air turbulence? How are we seeing that evolving at the moment?
What is clear air turbulence like? How do you find it? It's a bit of a dark art. Tell us all about it.
Well, it certainly is, because you just can't see it, right? Because if you're flying through a storm, at least you can see the storm. Well, you can see it on the radar screen if you're a pilot, but you can just look out the window and it's just obviously there. Our eyes can see it. But this clear air turbulence is invisible. Even on the radar, you just can't see it. You can be flying through clear blue skies, it can all look very nice, and then suddenly you can hit this turbulence that comes out of nowhere. And it is often found in the jet stream because it's generated by this thing we've been talking about, wind shear, the wind speed increasing with altitude. The atmosphere doesn't like that. And if the wind shear is strong enough, you'll develop these ripples that will grow over time. It's called Kelvin-Helmholtz instability. If any weather geeks out there want to look up the precise kind of science, what Kelvin-Helmholtz instability is the fluid dynamics kind of term for it. And yes, it's quite dangerous, precisely because the seatbelt sign is usually switched off. The pilots don't know it's coming. We do forecast it, of course, and that's another aspect of my work, is trying to improve the forecasts, but they're not perfect. And as a result of the fact that the wind shear is today 15% stronger over the North Atlantic, for example, than it was back in the late 70s, so we very clearly see that in satellite observations. As a result of that, the clear air turbulence has gone up as well. There's 55% more severe clear air turbulence over the North Atlantic today than there was in the 1970s, 41% more over the USA, and similar kind of increases around the world, really. Now, turbulence is rare. I don't want to scare anyone. Maybe someone's listening to this on their way to the airport and they're a nervous flyer, and the last thing I want to do is to worry anyone. Severe turbulence is rare. Only a few tenths of a percent of the atmosphere have severe turbulence in. So almost certainly your flight will not encounter it. But just given how many planes are in the skies, one of them will. And if you increase that by 55%, which is what we've seen, stands to reason that there will be more aircraft encountering turbulence. And the projections for the future are pretty terrifying. We've crunched some numbers here at the University of Reading in my research group, and we've calculated that by the 2060s, there'll be an increase of, well, a doubling, a trebling, a quadrupling in the amount of severe turbulence in the skies, in the jet stream. So, on those busy flight routes, transatlantic, trans-Eurasian, trans-Pacific, and in the southern hemisphere too. So flying in a few decades' time through an atmosphere with maybe 3 times as much turbulence in it is not going to be fun. And we're going to have to come up with ways of either forecasting the turbulence better so that the aircraft can just avoid it, or adapting the way we design aircraft so that they can withstand the more frequent turbulence that's coming. And that's another interesting point, is that we're still flying in aircraft that were designed for the atmosphere of the 1960s. The design specifications and the airworthiness standards haven't changed in terms of turbulence since the 1960s. They're still being used today. Now, the atmosphere has changed, and it's changing even more in the future. And so there's a point there about the atmosphere changing faster than the design criteria for aircraft. And that's a bit of a worry too. And so I'm looking into how might we change those design specifications to make sure that flying is still as safe today, as safe in the future as it is today.
I never thought of that before, and I am a little bit of a nervous flyer, I'm gonna admit. We've definitely got better, and I've been on a flight where we had turbulence and the plane just dropped, and people were walking around, and since then, I always have my seatbelt fastened when I'm sat down in the seat, but I had never thought about the fact that the planes are still designed for a climate that hadn't changed as much as it has now. So that's an interesting point that you just raised there.
What so I'm so curious to know, like, where did you get this information from? Because I know we have planes now have loads more sensors on them, and they're fantastic at helping those pinpoint forecasts for takeoffs and landing, and knowing exactly how fast the jet stream is. So how do you know this? What, like, so I know there's way more satellites buzzing around up there. There's so many of them, I don't even know what they do, but I know there's ways to extrapolate information, like to look through them. How do you know that? How do you know that?
Oh, in a way, we're blessed today as meteorologists with just more of information than we can cope with. We've got so many measurement um, sensors and satellites out there that we've got massive volumes of data, almost more than we know what to do with. Really, just analysing it is quite a big job. So we've got satellites, of course, since the 1970s. And improving all the time in terms of the resolution, so the detail that they can see. Uh, we sometimes forget about good old fashioned weather balloons, but I think they're important too. So this is a box of electronics called a radio sonde, a small box like this, and we tie it to a balloon, fill the balloon with helium, and just let go basically. And of course, up it goes into the atmosphere. It can reach 15, 20 kilometers. Eventually, the balloon bursts and it falls back to ground. But the package of electronics is reading temperatures, humidities, wind speeds, etc., and radioing the measurements back to a ground receiver. And these have been used for decades, of course, around the world and provide really important information for weather forecasts. Um, Another information source that we usually forget about is just aircraft themselves. I think most people don't know that when you're on a flight, you're helping to improve weather forecasts because the temperature readings that the aircraft is making are being sent back to ground and put into weather forecasting models through a World Meteorological Organization program called AMDAR. And so aircraft, people say that during COVID, when the number of aircraft dropped dramatically back in 2020, the weather forecasts actually got worse because we lost that information from the planes. There was some academic publications on that. So we rely as meteorologists on information from a wide variety of sources: satellites, weather balloons, aircraft, and aircraft these days, and for the past decade or so, have actually been measuring turbulence directly. They've got accelerometers inside the aircraft, so little tiny devices, same thing that we all have in our smartphones and controllers for video games, etc. Just cost a few cents. And they measure the acceleration, which we convert into a turbulence measure. And that information is available too, and we really rely on that for testing our turbulence forecasting methods. So we have a treasure trove of data available to us now as meteorologists working on turbulence. Really a great time to be working in this field because in the past we've been held back by a lack of data, I think, but that's no longer the case, thankfully.
Gosh, it's probably the opposite now. There's so much to look at.
Yeah.
But like, side note, love a radio sonde. Had the lovely privilege of setting off quite a few.
Mm.
Absolutely love them. The best little forecasting tool as well. It's interesting you mentioned the Kelvin Helmholtz waves because they made it into the updated um, weather atlas called Fluctus. They've an
Yes.
official name now, Fluctus.
Right, I saw that. I'd forgotten. Yes, that's good. Avesh finally recognised as the important kind of waves and clouds that they are.
I've seen them once in person and I got very excited. My friend who was with me thought it was hilarious because I did like a little happy, joyful dance. But
Yeah.
it's amazing when you see them because you can actually see how the atmosphere is moving. It's amazing. It's to see them in person is just like you have to be quick because they go very quickly.
Yeah.
They do. They last about 15 minutes. So you've got to get your camera out and take lots of photos. And they've got that characteristic shape as well. There's no other cloud that looks quite like them because it's that kind of overturning sort of shape. And interestingly, Vincent van Gogh, in his paintings, you can see a lot of these. Well, they're thought to be essentially Kelvin Helmholtz waves. They've got precisely that shape and structure. So it's thought that that's what inspired him.
I did not know that. Wow, yeah, they look like little waves crashing. Yeah, I didn't know that. How cool.
A quick question to ask you: can we also use lidar as well to measure turbulence? Is that another way that we can look at it?
We can. And so I mentioned that on aircraft, you can't see clear air turbulence, CAT, on the radar. But indeed, if you use LiDAR instead, there's some evidence that you can see invisible turbulence. Now, LiDAR is very similar to radar. It operates on the same principle. You send out a beam of energy and you look at the reflected energy, and that tells you about things ahead. Um, but if you use a LiDAR with ultraviolet light, so it has to be an ultraviolet laser, that's the right kind of energy or light to use. There's evidence that it can detect clear air turbulence 20, 25 miles ahead of the aircraft, which is just enough time to put the seatbelt sign on. Now, it's not being used on any aircraft yet. It's a big, heavy box. I don't know whether you've seen a LiDAR. It's a massive, heavy box. No one wants to put that on an aircraft. It just wouldn't fit for a start in the nose cone, which is where it would have to go. And it's expensive, and probably the business case for retrofitting a fleet of aircraft with it is negative currently. The aircraft would spend more money than it saves through the avoided turbulence. But that might change in future. Radar was very expensive as well when it first came out, but it eventually, miniaturized and the cost came down. Maybe we'll see the same happening for LiDAR. But certainly we have ground-based LiDAR that can see turbulence, and that's one of our key information sources for turbulence in the boundary layer, the very bottom part of the atmosphere. So yes, LiDAR has a lot of promise there, I think.
LiDAR is amazing. I worked on it about, well, I have a different degree in something else. But I was working on some early LiDAR data a long time ago, and it just blew my mind. Like the topographic information that was coming back is like I'd never seen such a detailed. I used to work in marine, so like bathymetry. It was just astonishing. So I can only imagine how it's moved on and how it's likely. I mean, if it's going to help aviation, maybe it is. I mean, money talks, doesn't it? If people are having more comfortable flights, and I'm sure, I'm sure at some point lidar will come into it and somebody will miniaturize it. It's fascinating.
Hopefully, yeah. I think there's airlines. There should be a airline should kind of advertise that they're the least
Mm.
turbulent kind of airline. I would have thought there'd be yeah. Do you think people would buy tickets for the
Yeah,
airline that said,
I do.
we avoid turbulence? Because different airlines have different policies. Some of them just put the seatbelt sign on and fly straight through the turbulence because it's usually not dangerous. It's not very nice, not pleasant, but it does injure people, but that's quite rare. Whereas other airlines have a reputation for taking every possible measure to fly around the turbulence. It might extend the journey time and burn more fuel, but at least it'll be smoother. I don't know if people would pay an extra £5 or £10 for a ticket on a plane that sort of, well, you'd never be able to guarantee the journey to be turbulence free, but at least you might be able to say we're an airline that takes more care to find the smoothest route.
Yeah, I aviation is my background in
Mm.
forecasting, so I'm very comfortable with flying. I'm like really, I know there's so many nervous flyers out there, and I try and say it to people. I'm like, you know, like pilots are more switched on if there is actually a little bit of bumpiness. I mean, they're more interested, they're more engaged. I'm not actually afraid of flying at all, but I appreciate that other people are, and I actually think there is a little marketing case in that if you're like flew with, I won't say any particular name, but let's say you flew with one airline that I think I would pay. Well, I know people I think that would pay a little bit more if they were advertised as somehow you know, I think
Yeah,
there's a lot more people afraid of flying. I know loads of people do it, but I do think there's an undercurrent of nervousness amongst a lot of people.
yeah, I think so too. And there was a famous guy, I won't mention the name of the airline, but there was very sadly a turbulence fatality recently on a flight. First time that's happened for a long time on a big commercial flight. Made all the news headlines around the world, and the reputation of that particular airline measurably dropped in the days, weeks, months afterwards. People were more reluctant to book with that particular airline. Perhaps it wasn't really the airline's fault. This is what happens when a name gets stuck in someone's head and a particular turbulence encounter gets attached to that airline. I'm sure it bounced back eventually, but yeah, I agree. I also think there's a market for an airline to say we're the smoothest airline.
And my background, I don't have any. I've never done any aviation forecasting. Mine's more like roads and energy, and I didn't know that there are some airlines that avoid turbulence more than others. I had no idea that that was the case. So I do think it would be interesting. I think there was.
Gemma's like,
I'm like, how
tell
do you
me,
do
we'll
this?
take
Now
notes
I'm really interested
afterwards.
to know which
Yes.
airlines. Like, is it an airline that I would go with, or I'm like, oh, I'm really interested now, so I'm gonna have to ask afterwards.
Yeah, they don't advertise this, right? But when you talk to pilots, you find out, and it's not written down anywhere, so it's not official information. But it is, everyone sort of knows, everyone who works in the field knows that this particular airline just puts the seatbelt sign on and just flies straight through it because they're quite price conscious. They don't want to waste fuel. Whereas other airlines, they just take a more relaxed approach, and they'll fly around it, even if it has other impacts, costs them more.
But
So, yeah.
but to
Really
emphasize, like
interesting.
you say, actual turbulence, like really dangerous turbulence, is
Hmm.
still quite rare. And the little bumps that you might feel that kind of gives everyone a bit of a rattle.
Mm.
Like it's not actually bad turbulence. My biggest gauge is cabin crew. If there's any whiff of any nervousness off them, maybe I'll think, oh, I should probably I should probably, just be a little bit mindful. But they're normally just, right, everyone sit down and they just have to sit down because they have to sit down and they're not nervous. And that's normally your good gauge. They're up there all the time.
Yes, they know what they're doing. And in fact, they are more likely than the passengers to be injured just because of their job, right? They've got to be moving up and down, securing the cabin. And so, yeah, the injury rate among flight attendants is higher than it is among passengers. As long as you've got your seatbelt fastened as a passenger. Well, there is one thing that can go wrong, which is that, and I have heard this happen, which is that the overhead luggage bin can accidentally just open up on its own, and some luggage can fall out and hit someone. That does happen. It's very rare, but yes, it's virtually a guarantee of safety, really, if you fasten your seatbelt.
Thank you so much for all of that, Paul. It's been amazing. But we do want to get to know you a little bit better in a slightly different way. And we would like you to answer some of our get to know me round questions.
Oh, okay. Wasn't expecting this, but go. I'm ready for it.
We've got two that are weather related, and then the others are just totally random. So the first one is, what is your favourite season?
Oh, I like them all in different ways. I'm going to be really annoying here and
Oh,
not
that's
properly answer the
that's
question.
that's very PC, correct? Yeah.
If it just had summer, if every season was summer for the rest of my life, I'd get very bored very quickly. And the same for winter, and the same for autumn, and the same for spring. I like the change. I get bored easily. Maybe that's what that says about me. I don't know. Um, yeah,
I don't know. Claire Nazir was the only other person that answered that who said she loves them all.
yeah, it's the
Normally
best
people like
answer.
one, but she likes them all in different
No, if
ways.
it
So
was summer
no,
all the
I
time,
mean,
I'd get bored. I'd want it to cool down a little bit. If
yeah.
it was winter all the time, I'd get bored of the cold. I just like the fact that it's always changing.
Lucky we live here. We're very lucky, aren't
Yes.
we, that we have seasonality.
Mm.
Yeah, we've had this conversation a lot on the podcast about how we are lucky that we live somewhere where we have seasons and our weather changes so much and we get to experience so many different types of weather. So,
Mm.
yeah, I
Yeah.
think we're lucky to have seasons.
Keeps life interesting. Yeah.
Yeah.
Keeps
Every
me
day
in a
is
job.
different.
Yeah.
Okay, this is the next weather related question and then they go random. What is your favourite type of cloud?
Oh, it's got to be the Kelvin Helmholtz, the newly named Kelvin Helmholtz. Is it Fluctus? Is that the right
Fluctus,
name
yeah.
for it now? Oh, I just
Yeah.
think they're beautiful. I don't think I've ever seen one in real life. I've seen photographs, but I'm hopeful I'll be out one day because, yeah, they're usually invisible, right? We've talked about that, and so it's only if the conditions are exactly right about the humidity and the pressure that you get condensation of water vapor and you can see them as clouds. I don't think I've ever seen it, but I live in hope.
I wish that for you. I really do. They're just I've actually seen them a handful of times. I feel very lucky. But I know if it's your favorite cloud, it will the moment will come. It'll be a lovely moment of joy when it
I hope
happens.
so. I'll have my camera ready.
Mm.
Yeah, be quick because I was not so quick. The picture I got was really rushed, but I still remember it. But it's when you see those clouds that you don't see very often. Like I remember quite recently for the first time I saw Momatus clouds.
Mm.
I was so excited. I was with my brother. He was like, "You're just taking more pictures of clouds." I was like, "Yes, but that's okay. You can't have too many pictures of clouds." But I just remember I was like, "Wow!" When you actually see them
No.
in real life, it's so special. It really is.
Yeah,
I
I
think
think I used to weather observe as well was one of my shifts that I used to do, and I used to just think to myself, oh, this is just great. I get to just
Mm,
report all the cloud types.
mm,
But I do take, but also they tell you so much about what's happening in the sky. They are
mm,
it's like the first cumulus cloud that is made on any one day tells you already how well your forecast is doing. So
yeah.
there's a lot more to it than just the beauty of it. You get to see the
It's a good,
atmosphere
good,
talking to you.
good way of tracking the jet stream as well, because you just see the
Oh,
clouds are moving. You think, oh yeah, there's the jet stream. Which way
yeah,
is it
and
blowing us?
sometimes that
Yes.
way,
Oh yeah, you see
and
the.
then you can tell
Mm,
that the front coming.
yes.
Okay, now we're going random. If you could have a superpower, what would it be?
Oh. If I could have a superpower, what would it be? I'm going to take a minute to think about that. If I could have a superpower, what would it be? Would I actually want one? I'm not sure I'd want one. I just think, it sounds good, doesn't it? Superpower. Maybe I'd fly like Superman, or I don't know, time travel. I just, I'm thinking I don't want a superpower. I just quite like being a normal human being with who does normal things. Yeah, you've caught me off guard with these questions,
Well, it's
Ashley.
an interesting one because it brings, like, do you want to do you want to fly? Do you want to breathe underwater? We had somebody recently just say they just want more time because they're so
Yeah.
busy.
Okay, I'll take
Like,
that. Yeah, more time was always good. Yes. Okay, I'm going to borrow their answer. I'm going to steal their answer and say I'd
borrow time.
like to not forever because that could be troublesome as well. But
Yeah.
yeah,
Yeah,
another
she was
few years.
saying just like on a day when she's just got a really long to-do list, she could just stop it for like an hour, get
Mm,
an
Get it
extra
done.
hour, and then she just carries on. And then she might do it again in like 2 months' time or just whenever she wants. It doesn't have to be like all the time. It's just when she
Yeah.
really needs like an extra hour or two.
yeah, actually, getting the children to bed on time, is that a superpower? Because
Yes,
I can't
that
do that.
definitely classifies as the superpower. And then
Yeah.
the superpower would be to get them to stay in their bed the whole night by themselves.
Yes. Okay. Okay. That's it. A bit more time and children in bed by 9, please. That would be.
That's a good one.
Mm.
If you were a fruit or vegetable, what would you be?
What would I be if I was a fruit or a vegetable? I feel like I'm being interviewed for a job here, and you've got these.
Yeah, some random modern questions.
I would be. What would I be if I was a fruit or a vegetable? Um, I don't know. I don't even know how to answer that one.
Well, the interesting thing is people come up with an answer. So
Mm.
we've had apples, oranges. I'm a mango. Um,
I'm a potato.
you're a potato. Yeah.
We had mushrooms,
Mushrooms,
pineapple.
pineapple, strawberry. Uh, we've had lots of them.
Yeah, we
Yeah,
have.
Hmm.
I can tell you my favourite fruit and vegetables, but it doesn't mean I want to be one. So that's not really answering the question, is it? I'm just going to say, I'm going to say tomato. I don't know why.
Well, they are neither a fruit
Cherry
nor a
tomato.
vegetable, are they?
True, they're on the border, aren't they? They're a bit of
Yes.
both. I'll be a cherry
Yeah.
tomato. Nice.
Multifunctioning and grown locally.
Yes.
Great answer.
If you could invite one person to dinner, and it can be anybody at all from any historical time frame or even a fictional character, who would you invite?
Oh, that's a good one. Um, all right. Here's a bit of information about me. Then I nearly didn't go into science. I nearly went into music instead. When I was about 17, it was one of those sliding doors moments. Should I become a scientist or should I? Because I play the piano, and I for a short period of time thought I might want to be a concert pianist, and that's what I would do. Um, and in the end, it was my piano teacher who said, "Actually, Paul, I think," and maybe she was trying to let me down gently here, but she said, the way she put it was, if you choose science for your career, you can still do music as a hobby. But if you choose music for your career, you can't do science as a hobby because you really need to have the expertise to be a scientist. You can't just dip into it as an amateur. But I think she was really telling me I was not good enough, really, in a nice way. Anyway, it's all worked out well. I do still play the piano, but I would probably choose a composer if I'm allowed someone who's dead. I would
Yep.
probably choose Frederick Chopin, the
Oh,
composer,
yes.
Polish composer. I play a lot of his music. I'd like to have a chat with him. He writes the most beautiful music. I don't know whether he ever wrote about the weather. He did write something called the Raindrop Prelude, which has got this raindrop note in it. It sort of just constantly plays throughout the whole piece. So I'd have a chat with him. I don't know, not sure whether he was a nice guy or not really, but I would like to just get to know him and ask what inspired him and how did he write all this beautiful music.
He's, do you know, my other half loves Chopin, and
Mm.
I was joking, just say, oh, you're listening to Chopin, like it's just like this silly ism, that we have. But it's interesting. I called you a rock star of science, so maybe you are doing both.
Yeah, well, if I have another life, maybe I'll choose differently and I'll go
Yeah,
into music. But I think it's quite hard to make a living as a musician. I think it's really hard, actually. Concert
yeah.
pianist, hotel rooms, travel, not much money, etc. Not much security and stability. So I don't have any regrets.
Maybe down the line you'll get to do it in a way where you're not relying on the money of it, and you get to do it just for the joy.
Yeah,
Yeah.
retirement hobby. Yeah.
And our final question is, what's one thing that you wish everybody knew about the jet stream or about turbulence? Either of those.
Mm. Back to weather related questions. What's one thing I wish everyone knew about turbulence? I think I would say that although it sounds awful and you see pictures and videos of injuries and occasionally, as we've discussed, sometimes fatalities. Um, and I've seen this picture, quite a famous picture of an aircraft that was flying through turbulence and one of the engines broke off in the middle of the flight, just from the turbulence, sort of made it unstable. It landed safely because it had other engines, so it was all fine. Although it looks terrible and it sounds terrible, it's rare and it's usually safe, and it's certainly not a reason not to fly. So sometimes at a conference, I'm the last speaker on the last day, and I know everyone's going straight to the airport, and I'm just telling them how turbulence is going to treble, and I can see the worried looks in it. So turbulence is rare. Your flight probably won't encounter severe turbulence. Someone's flight will, but it probably won't be yours. And even if it does, if your seatbelt's fastened, you'll be safe. And so I think a lot of the time when I talk to journalists and they're reporting a paper I've published, I think that the headlines are terrifying about turbulence trebling, severe turbulence, and makes you think we'll never be able to fly in a few decades' time. So I do like to just reassure people that turbulence is not pleasant for many people, but usually it's safe. And keep your seatbelt fastened. That's what the pilots do. Just do what the pilots do and relax and enjoy the flight. Some people like turbulence. Have you met people like this? They say they love it. It
The
sends them to sleep,
pilots.
like being rocked. When you're a baby and you go for a
Yeah.
drive to get you when your parents to get you to sleep. So some people like it, but I would like everyone to know that it's not as bad as some of the media reports would have you believe.
I think that is a very fitting final comment. Thank you very much.
Thanks, Ash. Thanks, Gemma. Thanks for having me on the podcast. It's been a pleasure.
Thank you so much for joining us today. It's been fascinating, and I know that I've learned loads of stuff that I didn't know. So thank you so much. If people want to follow you or find out more about some of the research you're doing, where can they find you online?
I'm on LinkedIn. I'm on the platform that used to be called Twitter. I still call it Twitter, but yeah, X. I'm on Blue Sky. Um, and I have a website as well, which people can look up. So I'm happy to connect with people with questions. Please get in touch.
Amazing. Yeah, if you've got some questions, definitely. I mean, I know that people that work in weather and climate questions, they love answering them. So any questions, we're always happy to answer them. Same with us. If you've got any questions about the weather and climate, you can reach out to us. We are on social media for the love of weather. If you have enjoyed this episode, we would love it if you would subscribe, rate, and review, share the podcast with a friend as well. And as always, we just hope that you leave this episode loving the weather just that little bit more.
Thanks for listening. Bye.